Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Houston, we are going to learn some super cool stuff today about a sedimentary rock. You think rocks are boring? Look at that rock. Is that like the coolest thing you've ever seen? Inside the Grand Canyon is where you find that rock. Let's review where we're at. Remember, igneous rocks comes from magma. All right, so you have liquid magma and it turns into igneous rocks. And then over time, the igneous rock breaks down through erosion, transportation. We're going to talk all about this later on in the year. Deposition, diagenesis, there's a fancy word. It means like turning into a rock. Okay, and then we make this sedimentary rock. These are rocks that are composed of broken parts of igneous rocks. That's where they come from. They can also come from broken parts of metamorphic rocks later on that. But mostly they come from broken igneous rocks. And it turns out there are 4 kinds of sedimentary rocks. Hello. They are called, Mr. Bergmann doesn't know how to pronounce, detrital? I think it's detrital. I don't know how to pronounce it. It was in the book. So it's called, I can spell this one, chemical, biochemical, and organic. And actually the detrital are the most commons. So we'll spend most of our time talking about these bad boys and then a little bit more on these. So let's talk about the detritus. The detritus, actually, remember, they're coming from sediments or broken parts of other rocks. And so the way we look at them is on the size of the grain. Does that make sense? It could either be bigger than 2 millimeters, so the size of the pieces. Can you see how this piece right here is like got lots of big crystals, if you will? And then, or gravel, right? You can understand gravel is going to have angular pieces. So it's getting different. As it goes down here, they get smaller, right? And you know it's sand, right? We've all been on the beach, right? You've been to Galveston, and there's a beach, and it's a sandy beach, and that's sand, but sand, when combined, makes sandstone. Does that make sense? You can get even finer. You get silt. Silt is comprised of really tiny particles, and crazy small is clay. And they have these numbers, right? How many percentages of millimeters. So it really is based on the size of the particles. You think of igneous rocks that break down over weathering and time, and then somehow they cement together and become a sedimentary rock. My wife and I took a trip to Arizona, a very famous place, Sedona. These are all right here filled with sedimentary rocks. And so the question is how they got there and why are they making cool mountains? And here we are right here. So we'll talk about that in a bit. Now let's go to the other type, the chemical, biochemical, and organic sedimentary rocks. Now these are interesting is that they come not from deposition. Again, we'll talk about that in a minute, how that happens. But they come from more like evaporation, all right? So you've got like a stream that flows down a mountain. So this is a stream, flows down the mountain, forms a big lake, and then the sediments settle out to the bottom, and then all the water evaporates, and it leaves back behind some different kinds of chemicals, right? And these are the types they have. They can be a limestone, so that's the fancy chemical is calcium carbonate, and as happens, that's the chemical symbol for calcium carbonate, and then you can make limestone, and even chalk is a kind of a cool one. Chalk actually comes from that same process. But the interesting here is that this one is biochemical because it also comes from microscopic shells and clay. So clay mixed with like little dead creatures, right? Those snails and things of that sort, and it makes chalk, very fine grained. And then we can have the other ones, gypsum. Gypsum is what we find in our drywall and plaster of Paris and stuff. Rock salt, right? So if you have like at the Great Salt Lake in Utah, what's going to happen is that lake water evaporates and you get salt left behind. Here's the most famous chalk in the world. This is the Dover Cliffs of England, and that's made of chalk. Or you could like take it and then like make chalk out of it, like for your blackboard. That's crazy. But there's cliffs of this stuff, and these are a bunch of, if you like zoom in, you'll find like dead seashell things in there. It's a very famous place because it's right over the English Channel, and there's a lot of history that happened here. Anyways, take your history course, they'll talk more about it. So how do you get from a sediment to a rock? That's the interesting thing we want to talk about. Well, first what has to happen is you have to go, so yeah, you got all these sediments, you have to get them to settle. So again, if we go back to this picture, maybe there's not a picture, but you got a mountain, water rolls, and then there's a lake, And then there's sediments and sediments and sediments. And folks, if we just look underneath where we're standing right here in Houston, I was reading up online, I think there's, I'm going to get the wrong, but like 6,000 feet of sedimentary rocks underneath us. Layer after layer after layer of these sediments, but they've turned into rocks over many, many, many years. And what happens is that they settle, and eventually there's lots of pressure, because if you go back to these 6,000 feet, there's a lot more pressure down here than the top here. There's just the weight of the earth on the top compresses it. So the first feature of causing something to make a sedimentary rock is compaction, which means put lots of stuff on top of it and it compresses, right? Like you ever played a game like a youth group, and then you get the kids on the bottom and you keep clapping. The guy on the top bottom doesn't feel so good because he's got a lot of weight on top of him, right? All right, so then the second piece, though, you must have cementation. So you need to have like a chemical that goes in here, and it's a cementing agent. So there's some chemicals that are like glue, that glue that'll make it stick. I mean, you could do this, like if you take sand and you put glue, it'll like stick together. So there's got to be some kind of a gluing agent, but you need both. They got to get real compressed, and then there's these chemicals that fit in, and then boom, make a sedimentary rock. So that's how it's made. It's not all that much of a rock science. A classic example is this: is the sedimentary rock that makes coal. Coal, one of the most important chemicals in the world, because we use it for like all of our energy sources, or sort of. I mean, there's other ways we do this, but when you get, now this is not from broken rocks. This is an interesting one. It comes from organic material. This is the biological kind. So you get a swampy environment, i.e. like Houston is a swamp, right? And underneath is all of this soil stuff, right? And this soil stuff has organic matter in it, and it becomes what we call peat. But if you bury it and you compact it, it turns into coal. Yeah. Lignite. And if you like keep compressing it more and more and more, higher, you get a harder coal called bituminous coal. And then if you really, if you push it in stress, okay, this is a metamorphic process, you can actually turn coal into another kind of coal. The best and most expensive and the most valuable coal is the anthracite coal, because it's going to have higher energy content, and that's the metamorphic coal. So it's kind of cool to see. So let's talk about some of the features of sedimentary rocks. Probably the most important feature is what we're seeing in this image, again, from Sedona. This is from the balcony in our place in Sedona. Yeah, I took that picture. It's cool, isn't it? Do you notice that there's like layers? You see there's a layer here and a layer here, and you see how there's like, and they call, the fancy word, they call that strata, or sometimes beds. There's different beds that are laid down. So and this is crazy. This happened underwater. It's obviously not underwater today, right? So it laid down this strata right here, this one right here, over many, many years, and it's kind of kept going across here. And then we have another layer, right? And then we have another layer down here. You can see the different layers that happened based upon under the water, and eventually this got pushed up. Again, how that process happened, we're going to talk about that later, but eventually it made its way to the surface. So sedimentary rocks aren't going to happen, even though we found them on the top of some mountains, which is crazy, right? It's formed almost always underneath water. So like at the bottom of an ocean or a large lake or an inland sea. One of the things that you're going to see in these rocks, well, here we go, is because they're sedimentary, oftentimes you find like creatures in them. Do you see this? Do you see this is a fossil? So inside of a sedimentary rock, you might see an outline of some kind of a little lobstery creature here, right? I'm not sure how big this rock is. I'm not sure this is a big one or maybe a tiny little one that is seen. I'm not sure of the picture, but you can actually see fossils. So one thing where are you going to find fossils if you're looking for fossils? You're going to find them in sedimentary rocks. You're going to find them in igneous rocks because they just burn up the creature. So sedimentary rocks are cool. In fact, we're sitting on a whole bunch of sedimentary rocks right now because like we're in Houston, we got 6,000 feet or whatever it is of sedimentary rock underneath us. Houston, no problems. See you in class.